In this lesson, we will be talking about interpreting circle graphs. In a circle graph, data are shown as parts of a whole. So the entire circle represents a whole, and each sector or piece of the circle graph represents a percent of the whole. So the whole circle represents 100%, and then we break each of the pieces into a percentage of the whole. A circle graph has a title. Now, just like other graphs that you guys have talked about over the years, we always have to have a title. Otherwise, there's no context or no explanation as to what this graph is about. Each sector is labeled with a category and a percent. A circle graph compares the number in each category to the total number. So we can't compare, for example, baseball to basketball. We're comparing baseball to the whole and basketball to the whole. A fraction of the circle represents the same as the fraction of the total. Sometimes a circle graph has a legend to show what category each sector represents. So in this case, we do have a legend. It's off to the side, and each color represents a different favorite sport. So pink is hockey, blue is soccer, orange is baseball. Sometimes these are written right on the graph, but it kind of depends on how you are doing. And so the example we're going to do, there is no legend. It's actually written as part of the information. In this case, only the percents are shown on the graph, so we only see the percent numbers on the actual graph itself. So our example, this graph shows Nathan's typical day. And so let's take a moment and just take a look at the graph itself. So it has that title, Nathan's typical day. He spends 40% of it sleeping, 22% at school, 8% doing homework, 22% doing recreational activities, and 8% of it eating. The first question asks us, which activity does Nathan do about a quarter of the time? So we have to think about what percent is close to 1/4. So a quarter of 100 is 25%. So remember, we have that 1/4 of 100, and that of 100 is the same as times 100. So 1/4 times 100 would give us that 1 out of 25, or 25%. So we're going to look for something that looks like 25%, and I have recreational activities at 22% as well as school at 22%. So those are probably the best answers. He spends about a quarter of his day doing school and a quarter doing recreational activities. Part B asks, how many hours does Nathan spend on each activity? Check that the answers are reasonable. So I'm actually going to scroll down to the actual worked out notes. We're going to talk a little bit about how we would do this. So from the circle graph, Nathan spends 40% of his day sleeping. There are 24 hours in the day, so we need to find 40% of 24. Now, I always call this my English sentence because it has the English words in it, and we need to turn it into a math sentence. So remember, this 40%, we're going to divide by 100 to get 0.4. We're going to write it as a decimal first. Of means times, so we're going to pull out our calculator and say that 40% or 0.4 times 24 is equal to 9.6. So he spends about 10 hours sleeping. He spends 22% of his day in school. So following the same pattern, 22% of 24, that's my English sentence. Turn it into a math sentence. 0.22 times 24 is equal to 5.28. Now we are going to do a little bit of rounding. That's closer to 5 than to 6. So he spends about 5 hours in school. And if you think about it, we have 5 periods in a day. They're all about an hour long. Makes about sense. That's not counting lunchtime, because lunchtime you guys are free to do some recreational activities. Because the percentage for school and recreational activities is the same, we can say that they are both about 5 hours. He spends about 8% of his day doing homework. So 8% of 24, that's my English sentence. My math sentence, 0.08 times 24. So multiply like we would whole numbers and then place our decimal point, or grab your calculator and do that. You get 1.92. So that's closer to 2 than it is to 1. So we're going to say he does about 2 hours doing homework and about 2 hours eating. To check if we are reasonable, we're actually going to add up the decimal numbers. So each of the exact decimals that we got, if we add them all together, we equal 24. If we added the rounded numbers, our number would be a little bit off of 24, but it shouldn't be too far off. So if we were at 22 and a half or 23 or even 25 or 26, I would say that's still reasonable because we know that we've rounded numbers. So we know that it's not going to line up to be exactly 24. There are some practice questions here for you guys to practice interpreting graphs. Please give them a shot, and if you have any issues, either send me a private message or comment on the assignment or the lesson, or send me an email and we can set up some time to talk about it.